Hello, and welcome to our virtual Lunch and Learn. Today we're talking about Connected Components Workbench drives, how to make it work for you. My name is Leanne Ireland, and I'm Marketing Project Manager here at McNaughton-McKay Electric Company. Presenting for us today is Les Smith, Drive Specialist out of our Toledo, Ohio branch. Out in the comments section, ready to answer your questions, is Steve Myers, System Engineer out of the Columbus, Ohio branch. We'll also have a Q&A portion at the end for Les to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just joining us, welcome to our virtual Lunch and Learn, Connected Components Workbench drives, how to make it work for you. Let us know where you're joining from in the comments. We'll be looking for questions as you have them in the comments while our presenter Les Smith discusses Connected Components Workbench and drive configuration shortcuts to save you time. Our specialist Steve is ready to respond to your questions in the comments as we go along. And we'll also have a Q&A segment at the end of Les's presentation. If you'd like to reach out afterwards, or if you have further questions for Les, you can send us an email at macamaclive@mc-mc.com. Be sure to let us know which session you attended, and we'll direct your questions to Les. We'll have the email address on the screen for you at the end as well. It looks like we have quite a few attendees now, so let's get started. Les, I'll pass it over to you now.
Thank you, Leanne, and good afternoon, everybody. Happy holidays. I'm going to be using Connected Component Workbench just for drives, and I'm going to try to show you how I use it. And at one time, I started up a drive, and it took the software a half hour to boot up, mainly because I didn't have the latest database in my software, so it had to upload, and also it had to correlate, and that frustrated me as an engineer. So I've tried to become more proficient. And just opening up today, I'm going to be showing you things that I have found out about the software, not everything possible. So, and it's just from a learning process. You see on the front screen, I call this file library. And this is all of the components that CCW will talk to. It's not only for drives, it's for programmable controllers, the Micro 800 family. It's for the panel view. And it's also, you'll see there, the soft starters, SMC Flex, SMC 50, and some other hardware that it does interface. I will only be talking about drives today. Also, you'll notice that this is free software. It doesn't cost a thing, and you can go up to the Allen Bradley download website and pull this down and install it on your computer. There is no support for pre-PowerFlex drives on this. You would have to use older software to talk to the 1336 family, 1305, the 160, the 161 family on that. So we'll move on here, and you can see I use this screen because it covers everything that Connected Components Workbench can do. I would recommend that for you If you're a drives person, put all the drives in your factory that are there, and you can use this for a library of information. Here we can see that I can talk to multiple drives at a time. And for this presentation, I have 4 drives over in the project area. You can see 525 tuned, 525 default, 753, and 753 million. I just named them different and use them for this particular lab. But you can put up multiple drives and go look at them and compare each one at a time. I'm going to take a look at the live presentation right now. And here you'll see the drives. And here I have the 525. You take a look at it down here, and it's just a single phase in, 3-phase out drive. Very low horsepower. We use it a lot for demos. Again, you put in 110 and you can get out 230 3-phase. Also, here is the 753. Take a look at this bad boy. He is, you can take a look, he's 22 amp drive, 753. And you can see over here the HIM, the I/O module, the Ethernet card. I got an Ethernet card on slot 6, I/O module on slot 4, and the HIM on slot 1. The software will tell you all the hardware you're connected to, and it's important to keep the same hardware at all times so it will interface properly. For instance, if I would take the HIM out right now, the software would back down because it's missing some hardware on that. But again, with this, I'm going to look at 4 different drives. 2 of them are live, 2 of them are static. They're both the same identical drives as far as the pair goes. Okay. We can look at the parameters on the drives and get help and definition from them. If we take a look here, right now we're looking at parameter 12 in a 525. We'll go live and we'll see where it can add to your knowledge base. Here we go. We'll go over to the 525, go to parameters, go to parameter 12. Now you see the help screen. I hit the question mark. I'll expand it, and there you can see the matrix that's involved with that particular drive. The drive that we're looking at right now is on Ethernet, controlled the speed and the start stop. So it's going to be a 155 value in that. But this matrix could help you figure that out. This is important. I've had customers who have had just a stray whisker go and hit one of the other I/O points and change that. And so they were getting erratic speeds on that. Okay, we'll back out of that and okay. We're looking at the compare function right now, and I'm going to use the 525 mainly because it's taking a while for your screen to catch up. There we go. Okay, because the it is much faster than the 753. 753 would take a minute sometimes to respond in certain situations. Okay, I'm going to look at the 525 right now. It's tuned. As you can see, I'm connected to it with this green line that's across here. And I'm going to hit the connect button. And at this time, I'm going to disconnect it. And as I disconnect it, now it's a static drive. I'm going to take that drive and I'm going to download from the project to the hardware. I just did that. And now the hardware has the same image as the project. And that's all, the only purpose of that. Now I could upload that and I would take from the hardware and bring that setup to the project. You could use this to download to multiple drives if you wanted to on this. Again, I'm going to connect to it. Again, synchronize, just it's going to come to a point and it's going to say, do you want the drive to look like the project, or you want the project to look like the drive? And it will make them look the same. I'm going to go to connect right now. And right there, we connected to it. We're alive. And we are we're correlated with it at this time. They're the same. So that's the purpose of those two. One of them only goes and correlates, the other one's upload and download. If I did that with the 753, that would take a little bit over a minute to connect to that. And then the next thing that we will see, we can look at the parameters. And again, I'm going to go live and look at the parameters on this. Now, you can, when we're looking at the parameters, there'll be a numerical order, and there'll be different ports, port 0 to the highest port. But I can go here and it says show non-defaults. If I hit that, that is going to tell me everything that has been changed in, in the drive. And as we can see here, the this drive has been set up. All the digital I/O have been turned off. We're using Ethernet for connection. Take a look. I got a live motor connected to it right here. And there's the settings on it. And then the only other thing I have is the Ethernet on that. So I can look, I can show all. Now show me everything, some 500 to 1,000 parameters, or I can look at only the changed ones. And that's for my benefit at this time. You can again, you can look at the whole list or just one parameter. And this now is a common look and feel with Studio. They weren't the same a while back, but they are the same right now. You can, when you look at a 525 or you look at a 750 drive, they both look very much like you're using CCW. Now we'll go look at the search. And this is, we want to look at a parameter. Now, most of us probably won't memorize all the parameters here. And again, we'll go live. And the, let's just say, I'm going to pick the word start. Now you can see here and this is on a 525, I'm going to change that over. I'm going to go to a 753 parameter. And again, I'm going to type in start. It shows me better. If you take a look here, see start's the very first word in the lookup, start's the last word in this one, and start is the middle word here. So anywhere in the name will be start. Now it also, I found, will pick units, I believe. Let's take a look here. Another good word to look up is motor. There you go. And this will get you to the motor parameters, setting up a drive. The most important thing is to set up the nameplate into the drive. And you can see here that we have a 230 volt motor. It's 1 amp, 60 hertz, 1750, 60 RPM. It's a half a horse. We're running a half horse motor on this 15 horse drive. The other thing, you could look for status. I know up in the 930s, there's some very good diagnostic words up there. So you could type 93. Let's take a look. Let's go back to the set 525. And earlier on, I learned MOTOR. You take a look down here, 498, 499, and 500 are set up by the tuning. So it goes out and tunes, and look, if I would at 498, this is how many ohms the motor is phase to phase on that. So that can help you in the future if you are looking at a degrading motor and it isn't the same as what you had in the tune. And also, this is where I looked and where I typed in ohm, and it will find that. So you can type in hertz, you can type in volts, you can type in amps, anything of value in the units there, and that will come up also. So I use that filter a lot to find things, find the parameters throughout the drive. And I'm stuck here.
Hey, Les.
Yes,
It's
ma'am.
Leanne. There you go. You were kind of cutting in and out. You all right there?
I have a stuck screen right now, lady.
Oh, okay. Well, let's just give, there it goes. Let's just give it a minute.
Okay, I'll go back here. I have the screens in front of me here on paper. Okay, I'll let that settle down. The next thing we wanted to look at was the connect. And again, we looked at the connect, upload, and the download on that. The other thing that I wanted to look at here was, take a look right here. This is my address, my Ethernet address that I'm looking at. If I go to the, let me go offline here. So this guy here, and if I click it, oh, look at this. This is going to tell me, this tells me where the Ethernet address is. If I was to look at a drive that was moved from one project to another, and that Ethernet address was there, it may not be valid. So all I have to do is hit clear path, and then when I went to upload, download, it would bring links in, and then I would use that to download and create a brand new path. Let me go back and see how we're behaving here. I'm going to jump in and out, Leanne. Let's see what happens. Okay, we'll go on now. We looked at the connect. The next thing I'm going to look at here is we'll go live and we'll look at the help screen. The help screen is my most valuable tool here. Now, the one thing I had on my slides, I had the software help, I put it in red. For whatever reason, on my computer, if I hit software help, it freezes the computer up. So I never use that. But here, product help. If I hit product help, now you see on 753, there's much more options here. This will give me help on whatever option I'm looking at the 753 or at the HIM, the IO module, or the Ethernet. It will show me the parameters that I can look at. And if I go here, I'm going to close this down, and I can look at the linear list here, and I can look at the faults. This is generally what I use it for. I'm going to go to the faults, and I can look up my fault number here and get a definition. For instance, motor overload. I would look at that, and that would tell me the conditions and tell me where to go to look for sometimes solutions on that. So that's the help for that particular one. If I go to the manuals, for instance, let's take a look here, the programming manual. Now I can bring up the whole manual, make it look nicer. And if I hit Shift, Control, F, and for this guy, I'm going to type in D, capital D, B, space, R. I'm already case sensitive. Leanne, your picture's in my way. And I can go take a look at what that means. And if I get down to, say right here, 382, it's going to tell me the type of resistor I'm going to use. Now I'm going to put the watts in. That's going to help me there. And here's the pulse watts, which is the amount of energy I can put into that resistor. You'll see that the default is 2,000. Sometimes we'll get up to 1,000,000 there. It all has to do with the amount of metal around there, but you call your vendor, you get that number. But the more interesting thing was, take a look here at 945 at limit status. This is going to choose the dynamic, the thermal protection. It's going to tell me that I'm getting close to the thermal units of on the computer or on the resistor. It's getting too hot, and that would be bit 12. And then down here on a different word, this is the alarm status. And again, it's going to tell me, I look at this bit for the dynamic braking resistor. And then down here is the fault, the word that will get me the actual fault that I have for the dynamic braking resistor. So I would use that search to help me out to find information. Okay, let's go back to PowerPoint. Okay, she is not cooperating. Okay, we'll go on here. We'll just go live. And now take a look at the help screen here. Instead of the manuals, I would go to Tech Support Wizard. I use this quite a lot. And what happens is, I'll just use it here. This creates a text file for all the defaults and all the information and all the buffers in the drive. In other words, if I get a call from a customer or you get a call, the first thing you'll probably ask, what was the fault? And they're going to say, I don't know, I just hit the stop button and got it running again. Well, the fault information doesn't stay alive when you download or upload your computer program to the computer, from the drive to the computer. They all turn to zeros. So he can't send you the file to tell what was wrong in this. So this will dump the buffers to a text file. And I had an example of that, but it would tell you all the defaults and it would tell you all the faults. So what would happen was you would see what the fault was that he could not remember. And we'll just take a look here. We'll go live here. And let me back out of this. Give you an example here. And if we got a 525 and we go fault, F-A-U-L-T. Okay, see all those numbers there, the fault buffers, first, second, third, they're all there. Okay, now let's go to a downloaded file, the same file virtually. We'll look at this says default, but we'll just take a look at him. And now it's got fault in there. These are all zeros. So the only way to get the faults out of the drive is to upload from the drive to the computer while it is live. So that's the value of the tech support wizard. This is liable to be 100 sheets, and you only have roughly a dozen that are worth looking at. So you'll do a search through there, but at least you have accurate information on the drive at the time, and they can send that to you. Okay, now we'll take a look at the upload and download, I believe. Okay, right here, if we take the 525 tuned, we can take a look here in the project. We can add a device to a project, and this would be a static drive. So if you wanted to add to a drive and put a default drive in there, and then you could load parameters in it from the field if you wanted to, or bring the live drive in, either way. The other thing here is you can remove from the project, and here you can interface with use links to connect to a drive to suck another one up into the project here. The reason I do this, let's just say I want to do a compare. If I do a compare here, and I use the defaults here, this is going to take a long time to do a compare because it has to verify that all the parameters are matching up from the project to the real drive. So instead, what I'll do is I can do two things. I can copy that living drive, and here is the living drive here. I can go here, and I can copy it and paste it down here. There will then be a static drive, and then I could, much like this guy right here, I can look at him. He's not connected to anybody, and I can look at the defaults, And there within 5 seconds is all the parameters changed from default. And as you can see, we're running a 230-volt motor on a 460-volt drive, and it has 18 amps capability, and I've only got 1 amp here that I need, and it is, motor nameplate is a ½ amp when I could be running 15. And truthfully, she doesn't tune well in flex vector, but she does tune well in rotate. But anyway, you can take these now and you can highlight them. It's going to change the priority here. Take them here, and you can copy these and put them on an Excel spreadsheet, and this will allow you to have documentation loaded onto your prints, etc., if you want that to. But if I did it live, it would take quite a while to do that. I can, again, we'll take a look here. I can rename the drives. Then where I've had 4 or 5 drives on the project, and pump 1, 2, 3, 4, 5, I can give it that pump name. And so it has an identity, and I can save that and ship that out to a customer. Again, I can delete, I can copy and rename. Okay, if we want to exchange data, we can do that. Well, let's do something else. We're going to have, I'm going to go to the 525. We have the control bar here. The control bar, now I have control of that drive. I have control of that drive right now because nothing else is vying for the power or the control. If I had it on a network, on the connected enterprise, I couldn't do that because I would have to fight and there would be 2 masters, and that can't be. So what I've done in the field is went into Studio and turned off the node connector to the drive. So Logix was not in control of the drive. Then I went out on Ethernet and I turned on the control bar, and I had control of that drive. The rest of the project could be started up, and I could flex the exercise of this drive. Now you take a look here, and here you can see I'm changing direction of it. And this to make sure it's a 525, he's not as noisy. I can jog it. And you see the little blue line there that gives me the speed of it. Or I can turn it on and change the speed here. And you see the hertz. But here I can help doing setup on this drive, making sure the directions, the correct direction. I could do tune if I wanted to. I could tune it. I could get it all set up, and when I'm all done, I could go back, and then I could turn a control bar off right here, and then I could give control back to the PLC. The PLC would have a tuned drive. It could interface with it and get on with life. We wouldn't have had to shut the PLC off, put it in program mode, disconnect it, etc. We could just do it in software. So that is the one thing I like about that here, that you can exercise a drive just with connected components and let Studio go ahead and start the rest of the machine up or for tuning. The other thing we'll have here is save a project as. This will allow you to save the project, put a name in it, save it in your own directory in the computer you have. Now, if you wanted to export it to another computer, we have to pick a different route. We have to go export project. If you was to take a look at the programs for CCW, they're in a file holder and there's many files. So in order for me to receive your project or you receive my project and have all the files, it's got to be archived. So we take and we use export project, and it archives it. The extension is CCW ARC, and you would receive that, and then you would import the project. And then it would expand and it would look just like what it is here. So that allows two different computers to exchange data. The other thing is, if you want to import a device, you have other drive programs from other Allen Bradley software packages. Drive Explorer Lite, Drive Executive Lite. You can take, and with this, you can look at the drive file, go and import that into a file for CCW, and then you can use all the features and the benefits of the software that we had for that. Okay, we'll go back and see how our software is doing. Oh, something's moving. Oh, she is staying there at page 8. Okay, we'll continue to go live here. Just this week, if we take a look here at a 525. I could compare, and there's such a thing called data logger. We won't talk about that today, but it would save parameter once a second to an Excel file, and you can graph it on Excel. But anyway, now take a look at a 753, and we'll go to the overview. Right here, the diagrams. These have been around, and they're only on the 750s for a long time. We'll take a look at that. There is a value to it. Let's take a look. I got a 753, and I'm going to look at the embedded digital I/O. One nice thing I like is I can actually size that to fit the screen. So right here, take a look on 753, you see the digital I/O. Remember that input 0 that's down on the bottom of the drive? That can take 115 volt input or 24 volt input, and take a look. They use the same common. It's either or. And also notice there's no filter there. Probably because that's used for the enable, and that needs to be as fast as possible. But other here, take a look up here. These filters here can be used. I'm going to have to enlarge this again. There we go. These actually are the parameters. For instance, you can look at the digital I/O in 220. You can look at it. You'll actually see it dynamically change here with this, but you get an idea physically of what's going on here. And here's the outputs. Take a look at the outputs. Here's the two outputs. You got a transistor output and you got a relay output. But for instance, let's take a look at the invert. The digital invert is word 226, and if you put a 1 in there, it will invert the output, i.e., let's just say it's the fault relay, has drive fault. You send that out to your interface, and you want that to go low whenever there is a fault. So you would invert it when there's not an out. Whenever there's not a fault, you would have a high. If you shut the drive off, it would go low. That's the same as a fault. But that gives you an idea on what things look like. The whole drive is in a block diagram, and if you wanted to look at that, you could look at other sections of the drive and see how it works. We'll just take a quick look at the I/O card here, and here's the standard cards. 6 digital ins and 2 or 3 digital outs, and the parameters that interface with that. But I used that to give an explanation recently to help people understand a little bit more on how everything is intertwined here. Okay, we'll go away from that. Okay, and again, that's only on the 750 family. The other thing that we're going to just mention, you have wizards here. There are wizards on every drive. A wizard is a graphical interface. You don't have to know any parameters, and it will walk you through the most obvious parameters used in a drive, the accel, the decel, the speed reference, the start, stop. And we have a wizard for every drive that we have. But we won't go into depth. That would be a whole nother display. Okay, Leanne, you still there?
I'm still here. Are you all done with?
Well, I'm all done. My PowerPoint has froze up, and I had some questions, etc., out there.
Okay, so let's look at the questions. How about that?
Do we have any questions?
Yeah, we had one question. And Steve answered it, but I'm going to read it off to you, and then you can enlighten us with that. So okay, so we have set up the parameters in RS Logic Studio 5000 or CCW. They look the same. So what's the plus that CCW has comparing to RS Logic and Studio 5000 or vice versa? And Steve, let me read you what Steve said. He said he uses CCW to start up the drives before the IT is connected to the network. And he says there are many PowerFlex applications that are standalone, which are not connected to the PLCs. You can connect directly to the drive using your laptop Ethernet port or use the USB port with the USB 1203 communications adapter.
Okay.
So
the obvious reason is that RS Network, Studio, is all-encompassing of the whole project. With that, I would say this: I would never back up a project on a HIM again, because it's already saved in Studio. But for instance, right now, my license is coming up on Studio, and I got to go get my license renewed, etc. That's difficult for me because I don't use Studio more than a dozen times a year, but CCW I use every day, as I showed you the library. So it's easier for me to go in and out with CCW, back it up, and get on with life. I can send the customer the changed parameters. I can save it, etc. Whereas if I had Studio, I would have to make sure that I'm updated. I would have to bring on my virtual drive. I would go connect to it, and etc. I would have to get on their network to do that too. So I use it because it's just quicker for me. Studio takes maybe 10, 15 minutes to come up. It's great, works well. You can see everything on it. But I use CCW just because it's quick and easy. I would still back up my program 3 different places. It's backed up on the project of Studio. I would back it up with either, I would back it up with CCW also. That way you can put it on different computers. Since CCW is free, you can train your electricians with that, whereas the Studio is a pay for. So I am pro CCW, not that it's better, but it's just easier for me to use since I'm not a PLC guy. Okay, young lady?
I think that sounds good. I hope you answered the bill. I hope I'm saying his name the right way. I think you answered his question.
Yeah, I would use them both. No problem. They each have their advantage.
All right. Well, thank you, Les. I think that covers all the live questions in the chat. I appreciate you and Steve for Steve being our resource out in the comment section, and I thank all of our viewers for their time today. We hope this session was informative and engaging for you. If you're not subscribed to the McNaughton-McKay YouTube channel, we'd love for you to do that for more industry content, and we look forward to seeing you live again soon. Have a great day and a safe and happy holiday.